Established in 2011, Evolution Mining is one of Australia's premier gold companies, with 5 wholly owned gold mines, as well as an economic interest in a 6th, and a well-earned reputation for consistency and reliability. Evolution's willingness to innovate and embrace new technologies allows us to operate our projects safely and efficiently and develop them to their fullest potential. Surrounded by the traditional lands of the Port Curtis Coral Coast people, Evolution's Mt Rawdon gold mine is located 75 kilometres southwest of Bundaberg in Queensland and is an open-cut operation that commenced in 2001. Since that time, Mt Rawdon has produced more than 1.5 million ounces of gold, with 105,000 ounces produced in the 2018 financial year. The site is currently undergoing a major cutback, which will increase the life of the mine until at least the 2026 financial year. To understand the importance of this challenge, it's first necessary to comprehend the mining process. The ore body is defined through resource drilling, sampling and assaying that allows geologists to define the mineral resource during the resource estimation process using advanced 3D software modelling packages to define the volume, spatial distribution and gold grades of the rock throughout the deposit. This is followed by mine planning and ore markups, production drilling, loading explosives and blasting, material movement and handling, stockpiling, processing, and then finishes with the pouring of the gold. The aim of the Mt Rawdon Buried Treasure Challenge is to improve our ability to assign accurate grades to the rill material. In simple terms, rill refers to the material that has been ejected or rolls down a slope, which is prevalent when blasting for a cutback. It was estimated in December 2017 that there was roughly 1.2 megatons of rill in the Mt Rawdon pit. In situations like this, where there's an open face or pit edge, material will continue to move under gravity like an avalanche and come to rest at a lower level in the pit. Because it's not always possible to access the lower area after each blast, this may result in successive blasted rocks covering the rill from previous blasts. As with any blast in an open pit, some shots are exclusively waste, which refers to material that doesn't contain gold, while some are exclusively ore, which refers to the gold-bearing rock that gets sent to the processing plant. Some blasts may even produce a mixture of the two. In most cases, waste material and gold-bearing material are indistinguishable from one another, and this can lead to planned gold not being recovered, which can result in a significant loss of income. This is a common industry problem associated with cutbacks. The goal of this challenge is to develop a method of accurately tracking and modelling the location that the different types of rill material comes to rest after a blast. Via the use of UAV video filming of each blast coupled with detailed UAV survey pickups of the resting position of material after each blast, a detailed 3-dimensional map of the rill material based upon gold content can be developed. This will allow us to assign accurate grades to the blasted rill material when reclaimed, and will help reduce the amount of gold-bearing material being inadvertently sent to waste stockpiles. Because each pit is different based upon its geometry, the mechanical properties of the material being blasted, and the blasting practices in use, it's important to note that the strategy of the challenge is to focus on modelling the rill rather than changing the blast process. The potential value of improving ore tracking and determining its spatial location accurately is estimated to be worth in excess of $1 million per annum to Evolution. Best of luck in this challenge, and we eagerly look forward to seeing the solutions that you develop for this problem.